All right, so we're gonna go ahead and get started for this session. What's wrong? Hello? Okay. Um, we will be covering, hold on. My name is Lily Taharuddin. I'm one of the senior consultant here in CM First Group. Today we will be covering 3 different topics for this Plex show and tell. The first one that we'll be talking about is Git for Plex. And then if you're interested in some of the performance improvement for Plex and REST API, please stay tuned on this session. It'll be very interesting. So let's go ahead and get started. The reason I want to cover this topic because I've worked with several customers that are not familiar or have not implemented some kind of source code management in their shop. So I think that's a bit concerning considering that source code management has a lot of benefits. You can keep track of all the historical record of your application development as long as the chronological details of your application. So what is a version control? What is a source control? Version control means that you have the information of the previous state and current state of your application. And source control kind of have the same meaning. It just says that you have every single snapshot of your application. So all these are all marked by what is called SHA in the source code management. It's a secure hash algorithm. So it will have a special code that you can refer to at any point in your application development. So it keeps tracks and manage changes of the code, historical record, who made the change, what changes were made to the file, which files were changed, when was it changed, and so forth. It also has branching and merging capabilities, which I'll go through a little bit details later, and traceability. So you can see who made the changes, when was the last time it worked, when was the last time it was broken. You can just see through everything. And you might also see this source code management terminology is basically the same. They all refer to the same tools. Track modification to a source code repository. So if you give a meaningful commit to all of your changes, then you would have a clean and maintained source code management historical log that you can use for any of your release notes. So if you're doing release to your customer, you can just kind of accumulate all those information into your release notes, which we're doing internally here in CM First. And if at any point that you have your application not working, you can always revert back. So you don't kind of have to walk back on the stuff that you did. You can just go to the repository. I want this one, this time that it was working before. You can always revert, and you always have a copy at any point. So the most widely known modern version of control system is Git. I think when you mention Git, probably most people would know and work with it. And to show you why it's so important, and it works on any operating system. What I mean is it works on I series, work on Z series, not just laptops, Mac OS or Windows. It works on any. The most common Git service that you might seen or heard of is GitHub, SourceForge, Bitbucket, GitLab, and Azure repos. For our demonstration today, we'll be using Azure repos. So you would ask, so how can we, get started on Git? How can we implement it in our shop? How does it work? So I'm just gonna go through the steps right now, and then we'll do a live demonstration after this. So first, you need to create a repository. You can pick any of the Git service that you prefer, and just create a repository. And then you want to clone the repository to your local machine. So this will be to any of the developers' local machine. And then you add the files to your local repository and then commit the changes. Now, when you do the commit to the changes, that just means that you tell your local repository, this is the version that I want to keep in your local repository. So it won't affect the the repository in your remote repository. It could be on your GitHub or any of your remote repository until you push the changes from your local to the remote one. Then the remote one will get a copy of the changes. And then when you push the copy to the remote repository, when you want another developer to get those changes, then they have to do the pull to their local machine. Now, there's a step here that says create a branch or a version. So you will always start with a master branch or main branch, depending on the Git that you're using. Sometimes they call it main, sometimes they call it master, but that's basically your main trunk. That's usually where you keep the stable version of your application. So if you want to make any modification at any point, we recommend that you create a branch. So that would be like a tip of the trunk of the main branch, the main trunk, and then you create a tip, and that create that separate branch. And then later on, you can make changes to it and then merge back to the main trunk. Now, if you have someone else that is in charge of the Git repository, you might need to open a pull request to the administrator to merge all your branch to the main trunk, so that you can put all your changes, new features, or bug fixes to the main trunk. Now, there are some files that you don't want to keep track of in the Git. For example, local settings or configurations or local models. In our case, a lot of these Plex developers would have local models. So we just want to check in group models. That is our single source of truth. Local model would be different for every developers. We don't want to check that in. Anything that is very specific to your local machine, you don't want to check that in your Git. So there's you can create a .git ignore in the Git folder, so that it will it will never check those files in the repository. All right, so let's go through the demonstration now. I'm going to start from we start from the very beginning. I need a little help here. How do I hide the panel? I can't see the browser tab. How do I?
You can make your browser a bit smaller.
It doesn't help. It cannot go full screen. Oh, I got it. Okay, good. I'm all good now. All right. So we've been using Azure repos internally. So I'm going to create a new repository now. Okay. So new repository. I'm gonna name it Plex show and tell. Create. All right, so it's ready to go now. So now we want to clone this. Right now it doesn't have any file, it's empty. We want to get a clone, so you can do it either by HTTPS or SSH. So we can just copy this and go to your local directories, any directories that you want. So I already have something here that I created. So I'll just do git clone. Oh yeah, I forgot to mention about the client. The one that I'm using right now is called Git, but there's other client that you can use. If you prefer command line, there's also something out there that you can use. So just paste the URL here and specify the directory name. Click OK. So this is doing the cloning. Cloning means it's gets the complete copy of what you have in your remote repository. Complete copy means it has all the historical record, everything. So it's very different from if you hear the terminology checking out. This is not checking out. Checking out, it means you're just getting the current working state. But this is complete copy of the repository. All right, so now I have this repository clone here and I have the directory. So I'm going to try to put this, as I mentioned, you don't want to put anything that is, local that would be different from any developer's machine to get checked in there. So I'm just going to put some Plex source codes, which I already have, and the group model. Okay, so now I have new files to commit. So now I'm going to do a commit to the main. Okay, there's another steps that I want to mention here. So yes, cancel. So I have this here, a pre-commit script. So this is important to mention. I'm gonna copy this inside this Git folder. I'm gonna explain that later. Okay. So let me commit first. All right, so because usually the first time when you do the initial commit, you can just say initial commit of if you have any meaningful message that you want to, enter or make sure it's recorded, then just put a meaningful message there. But for now, I'm just doing initial commit everything. So this means we're just storing all that, file versions that I think is okay now, is stable. I want to make sure that it's stored in my local repository at this point. Should I try again? So I'm just going to refresh just to show you we still got nothing here. It's still empty. And this is still committing now. It's going to take a few minutes. All right, it's a success. So I close this, I refresh, still nothing. Okay, now I don't think I'm going to have any changes for the day. So I'm just going to push to the remote repository. So there's a push here. All right, now this is going to remote repository. Okay, now you see the files that I just committed here. All right, so if you recall, I did add pre-commit script, what that does is stripping out all the information that is local to the developer's machine, depending on who is generating the Plex source code. So let me show you a code that typically you would see when you generate a Plex code without the extra information stripped out. So you would see this, the date and time and group model, location, local model. That would be different for every Plex developer. So we don't want to keep track of that in Git. Because we don't want to see this will be considered as a change in our Plex source code. So we want to strip that out. So let me show you the one when we commit it with the script on, that you will not see those information in our source code. So as you can see, it's much cleaner. So you will only see the difference when, there's the actual change in your Plex source code, which we care about. So that was the reason that we added that script. And also, if you have other files that, you don't want to commit, you just, like I said, just create a .git ignore and just put the extension of the files that you don't want to commit to the Git. All right, so now that we have that to the remote repository, and you would have another developers that come into your development team, and they want to just get into the development lifecycle of your application, they can just clone the code from the remote repository and then just do a fetch. So you do, when you want to get the changes, you do a fetch, and then when you have your changes, you want to give it to the remote repository, you just do a push. So that's just kind of the cycle that we have with the source code management. So I think I just want to encourage that it's going to be very beneficial. You won't have, it will save you a lot of heartburn if you have this in part of your development. You have backups of everything. You know what changes are made to the files. You can always go back to at any point in your application. If you feel like there's some version in the past that you really like, you can always look at all those changes, who made the changes, who needs to be blamed of the bugs in your application. You just see everything in details. So, I mean, once you use this, I cannot imagine that you can live without it, to be honest. So if you have any question, this is my email. If you can't remember, sorry, what was that? Question? Oh, sorry. Sourcetree is out there. Oh, you can also set up Git repository locally on a network machine if you don't want to use it. Oh. Are you using this in conjunction with Matchpoint? No, I'm just showing this just, from just the Git point of view. You don't need to use Matchpoint. Matchpoint has, different features. So if you want to have a better source code management of Plex group model, then you might need to look into Matchpoint. But this one is just for, it's free. It's something that you can use and can implement immediately without have to purchase anything. You can try it out and see if you like it. So you don't have to use it with Matchpoint. You cannot refer code inside the Plex module, just the generate code. Okay, you can check in all the group models, right? And you can always revert your group models. For local models, we don't want to check that in. So yeah. Yeah, you always want to consider group model as the single source of truth. So you always want to refer to your group model. Oh yeah, I can share that right now or share after the session. Okay, all right. I think I'm out of time, so I need to turn this over to April. Okay, sure, no problem.
Okay, so with Plex, our group model is ultimately our repository. And so you're keeping all the versions of your group model inside of Git. And you had mentioned that you can always roll it back. Ultimately, we have the same problem. I mean, if you roll back to a week, you've lost everything that's okay. I just want to make sure that there wasn't something here that I missed in that. Yeah, it's keeping all of your copies of your group model you can roll back to. But ultimately, if you roll back to it, you lose everything that happened from that point forward, right? Just want to make sure I didn't miss anything there. Okay, thank you, Lily. Yeah, we'll call that like an emergency situation where you ultimately yeah. Yeah, we won't go there.
So one thing about whether you're using Git or Subversion doesn't really matter for the group models. One thing that's really important is you actually, these tools all have a feature where you can actually lock a file. And so basically no one can update it. So essentially what you do is like anytime you're committing your group changes, you'll obviously pull down the latest version, do your Plex update. Well, actually, before you even do your Plex update, lock the group model in the repository. That way no one can mess with it while you're messing with it. And then when you commit everything, that lock will then be released for the next person to be able to use. And that's just a way to prevent things from getting all messed up. Okay, so here, let me share my screen now. Okay, all right, there we go. All right, hi, my name is Abram Darnitzer. I'll be talking about a couple of things today. And honestly, if you do not listen to me talk, you're probably gonna not like today because I'm presenting a lot today. So the first thing I'm gonna talk about is actually tuning your SQL for better performance. And so with Plex, we all know it, we all love it. It generates a SQL for us, we set up our data model, and it completely handles it all without us really having to think about it. It works really well for this. It's very easy to create something very quickly, to get something up and running, and it's reasonably customizable as long as you set up the logicals and the views to be able to do it. So, I mean, that's pretty good. But there are shortcomings. For one thing, the where clauses are all static. So there are a couple Plex patterns that will kind of dynamically build stuff, but I find there's shortcomings in those too. It doesn't really allow you to do any complex joins, only really stuff you can set up in the data model. And then the actual SQL terms that are available to it are very limited. I mean, it's literally select from this, maybe a join, where this, order by this. Like you can't group, you can't count, you can't select just a certain amount of rows. So those are all things that can actually cause problems the bigger your database gets and the more complex your system gets. So the consequences of this are we have code that looks like this. And I'm sure everyone has seen this. And actually, based on Andrew's replatforming presentation yesterday, you can also look at this as a way from DDS to SQL. So kind of the same idea. So because of DDS limitations, or because you just want to write stuff all in Plex, we end up with code that looks like this. And so essentially on the right, I have a function that's just counting the number of records on this table. I've seen this in literally every model I've ever worked with in my life. We all have it. And then the other one is just a function that one calls our counting function, then also just has a little bit of filtering saying if they're trying to position on a warehouse ID, and we're not equal to that, then we quit, or we don't use that record. And so because of that, we end up processing data sets that are much bigger than they need to be. And here, I'll just kind of show you real quick. All right, so, oh my God, all these Zoom controls are in my way. All right, there we go. So I have a very simple example. This is actually running that code that I showed you. And you'll notice it's taking like 5, 6, 7, 8 seconds to load up. Yep. And that's because there's a lot of data there. And it takes a little while for it to get all of that. It works reasonably well though. So 1 second, let me put this down. All right, 1, 2, 3, 3 seconds, not bad, but we can definitely do better. And the other thing that you might notice is I had to type in capital letters because, you know, again, the Plex comparator is going to be case sensitive. Obviously, you can add, you know, source code objects or call source code objects to make it all upper, you know, and things like that. But you'll see in a little bit with the SQL, it's much easier to do it that way and just not even worry about writing it in Plex. And so where really the shortcomings really start to show up is if I'm trying to filter on this count. So I only want records where transaction count is greater than 2. And I'm just going to let that go, and we're going to check back in on that in a little bit. Okay, so here are the stages of grief with your SQL. First is denial, obviously. Everybody's antagonistic towards my ideas. Like, no, I'm just going to build all these indexes. Everything's going to work. It's going to work so fast, and I'm going to show you I don't need to write any custom SQL. Well, indexes do help, but there are a lot of situations where an index is not going to help you in any way, shape, or form. For example, in our situation that we just did, the count, no index is going to make that go faster. It's just not going to work. If you're trying to filter on fields that aren't part of that index, the index is not going to help you at all either. So, I mean, unless you build like an index for every possible situation and have like a block fetch wrapper that then calls every possible situation, it's not going to work that well, or at least as well as it could. And the thing is, I don't know about you, I don't want to ever write a block fetch wrapper ever again where it has to call 5 different block fetches to fit all of my situations. So what do you do? Well, you start by creating your own SQL and just overriding what Plex is trying to do out of the box. There are a couple ways to do this. The simplest one is the select where statement. So the statement is literally select where, and then you pass in a field. And whatever that field value is going to be the where clause of your statement. So you can have just some Plex code that's dynamically building this where clause based on what the user has entered. And it's really good. It does a great job. If you're working just under a single table, it's probably exactly what you need. And also, if you are querying directly to the table itself, depending on your database engine, most of them will have an index optimizer, which will pick the proper index based on your select criteria. And it'll run basically as fast as SQL will allow. But if you're doing things from more than one table, or you need to do complex things, or like in our example, counts, execsql is going to be your best bet. So I know there are some people who are like confused about really how to use execsql properly, and I'll try to explain it as best I can to start out. So it basically works over a specific variable. So you do execsql, and then you pass in a source code object that is your SQL. And so then when you do the fetch next, you fetch next into a specific variable in the code. Normally Plex wants to do this under the view, but I typically think that's a bad idea because I like to have a pattern where I can just use it for wherever. So I just basically have some local view that I use as a field storage of what I'm going to fetch. And so the real thing to note at the gate is the order in which you have things listed in the select statement is the order in which the fields need to be in that variable you're fetching to. Like if you have a local variable called SQL data, and I have field 1 and field 2, I'll need to have field 1 in first, field 2 in second, and in my select statement, I have select field 1, comma, field 2. Okay, but there are quirks. This is Plex after all, there's gonna be quirks, there always is. All right, so there's a couple of things you just need to think about. So if you have a very kind of static where clause, or just mostly static information where you're just passing in like single fields into your query source code object, then you don't really have to do anything special. But if you're doing something where the where clause is fully dynamic, or your joins are dynamic, or even what fields are selected are dynamic, like this example here where it's just say where, and then we just pass in a variable to do everything. Then you're going to need to add a triple to that source code object called SQL statement type unprepared. And so don't ask me what this really does internally or why it's needed. I just know it is needed for these things. And so then by doing that, there's another little wrinkle you have to have. If you have any statically typed values or anything in your query, and if it's statement type unprepared, then you need to surround those statics with double single quotes. And I have no idea why. Please don't ask me. I just know to do this. It's been a headache in the past. So in this example, where I'm always joining where the company ID equals test, those are actually double single quotes, not a double quote, double single quotes. So that's just something to look out for. Okay. And the other question I get a lot because I rattle on about this a lot, is how do I know what to write? Well, it's really easy once you start using the Plex generated SQL as a guide. In Plex generated Java, you search for SQL string, and that's where it's being set. C++ has a separate file where the SQL is in, but it's very easy to find. C# also uses SQL string, so I think that basically covers all the ideas that you would have to have. And so what I do is I usually have like a Notepad++ open where I'm furiously copy pasting, making notes and everything. And I use that to kind of build the SQL over time in the way I want it to be. And then I go on to whatever my database engine is, and I manually test that SQL just to make sure there aren't syntax errors, because it's much easier to just catch them that way than to catch them when testing in Plex. So from there, then you just need to convert it all into Plex objects. So the list of possible, where filters, I have like message objects, for example, that I use to like concatenate the where clause together. And then everything else is just kind of already statically typed. And so you can see here, this is actually the SQL we're going to use to make our function work better. Speaking of which, let's see how that's doing. Oh, it finally finished. All right. Man, in my trial run, it didn't finish at all. That was going to prove my point way better. Okay, so what we're going to do, actually, I don't want to spoil the results. So let's go and replace our block fetch to use our custom SQL. So give me a second. Okay, made my code change. Let me just generate that for you. Come on, Eclipse. Okay, and let's go ahead and run our code. So let's go ahead and, all right, did it do it? Well, I have a good test to see if it did it. Of course, this worked flawlessly in all of my practice sessions. Okay, there we go. My fault. All right, let's see if it works now. Okay, there we go. You can see that was sub-second there. And let's go and do the count. Let's see how good we did. And there, instantaneous. So we went from something taking, I don't know, minutes to literally being instantaneous. So that shows the power of a good SQL query. So, all right, I need everybody to kind of say this in unison. I know I was expecting more people in person, but so the 5 of y'all, can y'all do that real quick? Wow, man, only one person did that? All right, well, anyway, so I do have an extra little bonus tip in here. So large data sets can cause a lot of issues, even if you're only trying to get one row out of it. If you ever use the fetch next surrogate pattern, this is an absolute like landmine. It's if you have a table, and the table I'm going to do an example of has 500,000 records, which actually in the grand scheme of some of these things is relatively small. And you can probably imagine that if getting the next surrogate taking even a second could be a real problem, because then you could have two people on a heavily used table trying to get the same, getting a surrogate at the same time, and they end up with the same surrogate, and then that's propagated, and now your data is messed up. So we need that to work as fast as possible. So here, let's go ahead and show the before, and then we'll do an after. So here, I mean, it's not going to look like much, but it's because this only has 500,000, but there, if it had a million, it just gets exponentially worse. 1001, 1002, 3. Yep, took like 3 seconds to get a surrogate. That's not good. All right, so let's fix that. So the easiest way to fix that is in your query, telling it to just fetch a single row. And so here I'll show you the SQL for it. So in this case, I just do select top 1, and that's going to save us so much trouble and only get the single record that we need. So here, let me do a little code swap. And leave that open, did I? No, I didn't. Okay. All right, so let's test again. Hopefully I did it right the first time. And of course I didn't, because I didn't pass my parameters correctly. I'm sorry, y'all, I have to prove this point. There's no going back. Oh, yeah, I didn't comment that line in, that's why. Okay. All right, it's compiled, and now it's gonna work, I promise. There we go. So it did it instantaneous. So, I mean, that's a very simple change to make that's gonna prevent a lot of headaches going forward. So in conclusion, constructing a custom SQL query to fit your needs is always going to give you better performance results than the Plex generated SQL. I mean, that's just how it is. But of course, I'm realistic. I don't think that everybody's going to rewrite every single function. So the question is like, where do I start? It's just really, you got to find the problem areas of your application, huge tables, very complex grid loads that are pulling from a lot of places. All those things can be combined and really, made to where everything is functioning and the user experience is just so much better. Questions? Let's see. Okay, there's a worry about SQL injection. Well, in reality, so when your code is, so this is why I kind of use, message objects, because everything is going to get just shoved into a single thing based on like an object that's entered. And so you can easily put in code in your Plex code to like remove, if the value contains a single quote, ignore it or something like that, something where somebody's obviously trying to hack your SQL. You can be in complete control of that in your code. So it's not like something that is just going to be vulnerable all the time. So you can easily prevent against those things. If you need to change table using SQL, how many? Okay, so impact analysis on these. Really, for the most part, it's you can just like do like source code searches for execsql, or if you want something more complex, Evolve IT, which there's a presentation going right now, is really good at parsing the model and find that information very quickly. So there's lots of different ways you can find this code if you need to make a change. Generally, for these, typically on databases, you don't really remove any fields or anything from a table. I very rarely see that happen. So really, it's more about just finding them and adding new information. One of the things I do for this, just to make sure that it doesn't struggle with database changes, is I don't ever reference like a full view. I'll just reference the actual fields in the view. And that way, if a field is added to the table, I don't need to recompile every custom SQL function I have, because unless that custom SQL function needs that new field, I can go make that change. But if it doesn't, then I can just leave it as is and it will still function the same way it did before. So even if it gets recompiled, it won't break anything. Hope that makes sense. Change your standards library for fetch next surrogate to some. Now, I really haven't, I haven't patternized the next surrogate just because the need, I just hadn't had a need to it for some of these things, but yeah, that can easily be patternized to just inject that select top one. So can you show us where you put the SQL statement? Okay, sure. Yeah, I'll show you kind of what the pattern. And so I developed this pattern too. So if you would like to see the pattern and would like to have it, I'm very susceptible to bribes. So that can really work out well. All right, so essentially I just have a simple pattern to mimic what single fetch does. And I mean, it's really not that complicated. Just really, it's all about just setup. And so in the execute, you do the execsql on the scoped source code object. Then I do a fetch next, and you can see I'm using a local variable called SQL data, which is where you put all the fields you want to fetch. And if everything's successful, then I set the fetch data equal to SQL data. I also put in edit points where you can manually build output as well. And so what you end up with when you inherit from it is you have this scoped SQL object. And you can see here, this one's very, very simple. I just have one parameter that's for company ID. And so really, here's my SQL, and I'm just passing it in just like you would any other source code or message object. And also, I'll show you the more complex one. So here's one that has used that SQL unprepared statement, because you can see the where clause is fully dynamic. And so really, it's pretty standard SQL. I just kind of have additional stuff to do a subquery to get the counts. And then in the actual function itself, there is code to build that where clause. So I always start out with like a base thing, just so I know I don't have a blank where. And so then if they pass in a warehouse ID, I add that to it. And you can see here, here's where I'm adding the uppercase items to where you don't have to worry about what, it being case sensitive at all. And so then if the count's greater, then I add that to the filter as well. So really the code itself is not that complex. Once you have your SQL query, it's pretty easy to kind of build those things. Let's see, did I miss any other questions? Oh, yeah, so for IBMI, so if you're running RPG, unfortunately, execsql does not work. It only really works for WinC, C#, and Java, unfortunately. That's mainly because just Plex generated RPG doesn't support SQL. It's all DDS access, so. All right, does select where, sorry, is there anything else that I missed? Oh, really? Oh, so according to Jeremy, there's some patterns shared to do the SQL RPG. I haven't seen that. That's pretty cool. Cool. If there's no other questions, I'll move on to the next presentation. Sure. Okay. All right. So let me switch over to the next one. There we go. All right. So now I'm going to talk about Plex and REST APIs and how they can work together. I'm still Abram Darnitzer, so don't worry, I didn't change. All right, so what is a REST API? REST API is an application program interface that conforms to the constraints of the REST architecture style and allows for interactions in a RESTful web services. REST stands for Representational State Transfer. All right, so in other words, without that dull as dirt explanation I just gave, REST APIs basically allow us to consume code and present our application logic in a very just standard way to where other applications can interact with it without either application really knowing or caring what the other thing is written in. So you just have two things that are just communicating. They're going to communicate in a standard format, and then each thing can consume or distribute that in any way that they see fit. For our application today, we'll be using JSON. JSON is pretty much the industry standard for these type of things because every language can easily parse it just because it's formatted in just a very nice, clean way. Okay, so one extra thing we're going to use is a tool called Postman. It's a free to use. There's paid upgrades API tool. It allows for you to interact with your APIs a lot better than just putting them in the browser. So if you ever are messing with APIs at all, just download it. It's free, easy to get, lightweight, and you can do all your testing there. Okay, so how do we consume an API in Plex? Well, in the most basic sense, a REST API is requesting from a REST API is as simple as making an HTTP request. Once you do that, then you can just consume what is then returned by that. So the API, again, does not care what language you're making the request from. It's just a standard HTTP request. And so for the purposes of this demonstration, I'll be consuming from the Open Movie Database API, which just is free to use up to a certain amount of times per day. And so nobody steal my API key and use up all my usage real quick. Okay, so where do we start? So let's begin to figure out what the HTTP requests should look like. So documentation for APIs is very, very important because as granted, the person using it doesn't need to know what it's written in, but they need to know how to interact with it. So every good API has good documentation. So here I'll go to, oh my God, all this Zoom stuff I'm away. All right. So this is the OwnDB API, and you can see here that there's a lot of documentation on what the parameters are and what you should do to how you should pass them in and what they will return. And so let's go ahead and make a quick request. So I'm going to go into Postman here, and where's my history? There we go. And so, oh my God, I need to get rid of all these Zoom things. Okay. So we're going to go ahead and make this request. And you can see our request failed. There's no API key provided. And so this, I did that on purpose to prove a point. All right. And so with a lot of APIs, there's a lot of different ways to do security. Very, very common way, as with this one, especially publicly available ones, is to use an API key. So this is the thing you register for, and this is the code specific to you. So once we add that to our parameter, it should work, and we'll see that in a second. So Other ways that you can secure your application is using like OAuth and HTTPS. You can wrap them using servicing tools like Keycloak. Lots of different ways to kind of protect your API if you don't want people from the outside or you don't want it publicly available to everyone. So let's go back to Postman, and I'm going to do the version with my API key. And you can see here I searched and it's giving me all these movie titles with aliens in it. So there it works. And that's now I can see what the data being returned looks like and what I need to parse. And so that makes it a lot easier when you're actually writing the code to parse it. Okay, so how do I do this in Plex? So we need to start out by making an HTTP request. And I apologize if this is quite small, but again, we'll be distributing the slides and you can kind of see this code. So essentially, we're breaking this up into several steps. So we need to make the HTTP request. We need to create the JSON objects in our Plex code with whatever the JSON that's returned. And then we need to parse that and get it into Plex fields that we can just use normally in our Plex code. So this is steps 1 and 2 in a single source code object. We're making our HTTP request and we're passing it into a Plex object field that's just going to store all that JSON. If your API was only supposed to return like one set of JSON data, then you could probably cut the number of source code objects needed down by a lot. But in this case, it's more of like a block fetch style functionality. So we're going to need to do several things beyond this. So now that we have the JSON object, we need to parse it into individual JSON records. And then we need another one that's going to parse those individual JSON records into the Plex fields. Okay, so here's the example of actually parsing it from the JSON array into individual JSON objects. So in your pattern code, you could think of the first one as your actual like executing your SQL. You could think of this one as the fetch next, basically. And so basically we have a fetch next and a JSON object from that. And now we need to just parse it into fields, and doing that in Plex is pretty easy. You use for Java, at least, you do the toString method, and then you could just put that directly into each of the Plex fields. So in this case, we're setting whatever the title, the year made, the image URL. And so you can also look into patternizing this code to make it a lot easier. I know Andrew's done a lot of work doing this with a product called HSync, which has a very good REST API tooling. So if you ever want to kind of patternize this and automate it, it might make your life a lot easier. So if you're interested in that, just please reach out to Andrew or I. Okay, so now let's look at the end result. So let me actually show you instead of a static image. All right, so let me start my server. That's one. All right, so let's refresh. Those Tomcats still not started. Live demos, y'all. All right, there we go, finally. Sorry about the wait. All right, so let's refresh and look for alien. And if I spell it right, I might get the results I want. And you can see here, we're pulling all this information, and none of this information comes from our local databases or anything at all. This is completely coming from that API. So you can see here, you can have as much information from outside sources as you need and consume them and use that information however you feel is necessary. Okay, all right, so let me get back to this. Okay, so that's one half of the API. Oh man, I'm running out of time. One half of the API items. So the next part is actually exposing your code. Depending on what language you have, there's different ways to do that. With TOEIM functionality, there's actually, and there's a way to do it in RPG as well. Our Matchpoint product can do this. Another shameless plug for me. For Java, we use Spring Boot and Quarkus, both of which work very similar. So it's really just whichever one you prefer better. And then C# and C++ do have some built-in stuff by Microsoft. For our example today, I'll be using Quarkus just because that's the one I chose to do. Not that it's any better than any of the other options. Okay, so to call it, it's not as simple as just directly calling the generated Java class. Unfortunately, Plex runtime kind of gets in the way. And so we need to kind of initialize a lot of things so Plex's call stacks and function stacks will work properly. And then manually call it and then parse the output as an array. And so here is an example of code that we're using to call Plex manually. If some of you feel dizzy looking at this, I understand it doesn't look great, but we initialize basically our OB application. And so then we can just initialize our call. We make our call and then we parse all the output array to be returned by this method. And so then from there, we just need to make our API method. In this case, we're doing it on the path of movies, and we're calling our method that we did to call Plex function, and then it's just going to return that output array as JSON automatically. So Quarkus does that for you. You don't even have to format it. So let's go test it. So let me. Sorry, I got to stop this. Yeah, I know. I'm trying to go fast. It's okay. We're only running into me presenting again after this, so I'm only hurting myself. Okay, so let's go into Postman and let's do and run this. And so this will actually be pulling from our Plex code, and you can see here we pulled up the movie that we wanted from our data. And so really you can do this with just about any Plex function you want. The process is exactly the same. You just kind of have to wrap it and initialize those Plex objects before you can really call. But again, you can do this and then secure it in any way you see fit. And then also, once your Plex code is deployed, then external applications can now consume it. This is an example of a React app that I wrote just to consume this. All right, so yeah, that's it for that. And I know I'm basically out of time, but is there any questions or anything? Okay, again, if you have any other questions you think of later, you can just always email me. I will get back to you as soon as I possibly can. And I always love discussing this stuff with people and how to modernize their application into the more, I guess, more standard environments that are available now. So, all right, well, thank you, everyone. And thank you, Lily, for her Git presentation as well. And stay tuned because you'll be hearing from me and Lily again right after this. So thanks, everybody.